This video shows an animation of the TAC, a tabletop automation center, performing hypothetical tasks on printed circuit boards. We'll start with a TAC equipped with a bi-level magazine on one side and a single-level magazine on the other. To accommodate the circuit boards, we'll use a slightly taller TAC frame, which places the carriage an additional 2 inches above the work table. As usual, for the sake of clarity, we'll take various items in and out of view during the animation. On the lower left magazine, we'll place 2 pallets, each holding 25 circuit boards. These 4 by 5 inch boards will be pre-mounted with an SOJ type integrated circuit. On the magazine's upper disc, we'll place 2 pallets to carry connectors to be installed on the boards. On the right magazine, we'll have empty pallets waiting to receive the boards we process. On the TAC's moving carriage, there will be a gripper on the left side. In her center, we'll have a rotary head holding a dispenser for spraying conformal coating. And on the right side, there's a heating bar to perform a solder reflow process. To begin with, we'll pick up a circuit board with a gripper and convey it to a rotary clamp on the work table. The table allows us to turn the board in any direction. In a similar way, the clamp can position the board either face up or face down. We'll also have blocks set up to support the work being done on the boards. Next, we'll bring a connector from the left magazine. For this application, we might use a vision system to help the gripper insert the connector's leads into the 4 holes pre-drilled in the board. After the connector is inserted, the clamp will then flip the board over. The TAC then repositions the table and carriage so the heating element can melt the pre-applied solder on the back of the boards to attach the connector's leads. As an additional task, the TAC will use the dispenser mounted on a rotary head to spray conformal coating from all 4 sides under the bottom of the SOJ integrated circuit. The coating is used to protect the J-shaped leads under the circuit's body. The ability to spray under lips and overhangs is a primary feature of the TAC's rotary head. After finishing with the board, we can then store it on the right magazine or back on the left where it came from. For that matter, we could stage another 50 boards on the right magazine for processing. Note, regardless of how the boards are staged on the magazines, the TAC can reposition them in any manner desired. As an example, here we show a board being turned 90 degrees onto its side. Another of the TAC's features is its ability to extend parts over any of its four sides and to utilize devices or other TACs to operate on product items from above or below. For instance, we could have positioned a device in front of the TAC to drill holes in the board. Or, with one of the rotary magazines removed, and with a device positioned on one side, the TAC could perform a process from both above and below the circuit board simultaneously in an inline fashion. In light of the TAC's capabilities, you can understand why we expect to see it handling many interesting applications in the years ahead.